Hello everybody, here's a little video about multiple representations and a little solving equation review. So multiple representations are basically some mathematical tools we can use to consider patterns, functions, and relationships, and they give us a full picture of what's going on. These four representations will kind of appear throughout the integrated math series, not just math 1, but math 2, math 3. All right, so what are they? Well, the first one I'm going to mention here is a situation. It could be a pattern, a picture, some sort of real world example. Also, there is a table. A table will consist of kind of two columns or rows, kind of you can set it up vertically or horizontally, that has the numbers paired, x and y values or inputs and outputs, whatever the relationship pairs are. Then a rule, and this is a description of the relationship. And it could be words or could be symbols, and it describes the relationship of the numbers. Finally, since we've got pairs, we can also look at this on a graph, and it will give us sort of like a visual tool to look at for a pattern. So here's an example. For our situation, we'll bring one from the class yesterday. I've got these tiles. For my table, I have the pattern number and then the number of tiles. So here I put the numbers that were here on the bottom and the pattern number, 1, 2, 3, 4. And then here I counted up these squares, 1, 3, 5, and 7. You can clearly see the pattern number is increasing by 1 and the number of tiles is increasing by 2. Next, a rule. Here, this is one that you figured out in your class, is that here if I multiply the pattern number by 2 and then subtract 1, that will give me the number of tiles. And then in symbols, if I'm going to use symbols, if I use like x and y, I need to make sure I identify my variables. Very important. So if x equals the pattern number and y equals the number of tiles, the relationship can be written y equals 2x minus 1. And then the graph. Here, notice that these are separated dots and that the axes are labeled. That's important. Sometimes graphs are discrete, like this one, where they're separate dots because there's not really anything in between these two. And sometimes they're connected when I can have any number in between. So quick review of equation solving skills. When you're asked to solve, what you're trying to figure out is the value for a variable that makes an equation true. We can do kind of two methods. One is kind of looking inside or using inverse operation. We're going to get more in depth, and first we're just really going to practice the basic ones. So like here I have 2x plus 5 equals 17. Now if I look at this, I know that really what has to go here is 12. This 2x has to equal 12 because 12 plus 5 equals 17. Now here I know 2 times some number is equal to 12. That's what this is telling me. And I know that that number has to be 6 because 2 times 6 is what equals 12. This is what I would call looking inside. It is really the same as what I'm going to do next, which is inverse operations, but it's sort of like just thinking of it differently. Is that really, to get that 12, what I was really doing in my head was I call this subtracting. It's the opposite of that adding that's here. I know that I'm adding something to 5 to get 17, and that something has to be 12, so I subtract 5 from both sides. Here, I know 2 times some number is 12. Well, to figure that out, I have to do the opposite, undo it, which is dividing, and it's really 2 times 6, that is 12. And so I divide by 2, and those ones, 2 divided by 2, that's 1, and then 12 divided by 2, that's 6. So here are two different ways of solving that equation. All right, everybody, I hope you have a great day, and I will see you all on Thursday.